Hello students. In our vehicle dynamics class, we were discussing the topic of steady state cornering. Till now, in the part 1, we have discussed some of the formulas that we will use to solve the numerical problems related to steady state cornering. The important formula is cot phi minus cot theta is equal to C by B, where phi, this angle phi is the outside lock angle and theta is the inside lock angle. C, this is your length C, pivot center, and B is the wheelbase. And another formulas that we have discussed was about turning radius. For inner front wheel, you can see the turning radius is RIF. This is the relation. For outer front wheels, this is the relation. Similarly for inner rear wheels and outer rear wheels. So based on these relations, we will discuss a numerical problem. This is your question, very important. The wheelbase of a car is 2.7 meter. That is B is 2.7 meter and pivot centers are at 1 meter. Pivot center that is C is 1 meter. Wheel track is 1.2, that is A 1.2 meter, and calculate correct angle of outside lock. So outside lock angle you have to find. See in this diagram, what is outside lock angle? The outside lock angle is phi for the outer tires. These are the outer wheels. What we have to find is outside lock angle and turning circle radius for outer front and inner rear wheels when angle of inside lock is 40 degree. So angle of inside lock, that is theta, is 40 degree given to you. So you have to find out angle of outside lock. So how will you calculate? You have to calculate phi. Use the relation cot phi minus cot theta is equal to C by B, where theta is 40 degree given to you. Cot phi, just put the, it is not 10, it is 1.0 actually. This is C. It is 1 meter given to you. Don't confuse it with 10, it is 1.0. It's a mistake here. So the cot phi is 1.56 and phi will be 32.6 degree. Another thing you have to find is turning circle radius for outer front wheel, that is ROF. You apply the relation from these, that is B by sine phi plus A minus C by 2. So this is B by, that is B is 2.7, sine phi you have calculated, plus A 1.2 minus C by 2. From this relation you will get the turning circle radius of outer front wheels, that is 5.11 meter. Similarly, turning circle radius for inner rear wheels, that is RIR. How will you calculate? See the relation B by tan theta minus A minus C by 2. Just put the formula, that is B is 2.7, theta is 40, A minus C by 2, and you will get the answer. So we have seen that for perfect steering, we must always have an instantaneous center about which all the wheels must rotate. So if you want a steady state cornering, in the first part I have discussed that this is your instantaneous center. And for perfect steering, or we can say for steady state cornering, this you should have an instantaneous center. For this purpose, inner wheels has to turn more than outer wheels. So your inner wheels always have to turn more than, that is theta angle is more than phi. Figure shows the links RA and SB are integral with the stub axles. These links are connected with each other through a track rod AB. So you can see this figure here. This is your link RA and this is your link SB. Or in the enlarged view you can see this is RA and this is SB. These two links are connected with AB, that is track rod AB. Okay. So when vehicle is straight head position, these links make equal angles alpha with the center line of the car. So as you can see, when your vehicle is moving straight, it is not taking any turn. The links RA and SB make angle alpha with the center of the vehicle. The dotted lines indicate the position of mechanism when the car is turning left. So when your car will turn towards the left, in this left direction, your RA, this RA will shift in RA dash, and your SB will shift in SB dash. So this is the dotted position, means when your vehicle is taking a left turn. So let L is equal to length of track rod. So this AB is your track rod. Let's say its length is L. R is equal to length of the links RA and SB. So this small r is the length of RA and SB. Refer to figure B, this figure. Neglecting the obliquity of track rod in the turned position, the movement of A and B in the horizontal direction may be taken to be same, each equal to x. So let's say this movement A to A dash in the horizontal direction is x, and this B to B dash in the horizontal direction is x. So sine alpha plus theta. So we will apply the formula for alpha. This is alpha and this is theta. So apply the formula for sine alpha plus theta in this triangle here. So this is your triangle, right angle triangle, alpha plus theta, sine opposite side over hypotenuse. So opposite side is this, that is y plus x, and hypotenuse is this, means r. So sine alpha plus theta will be y plus x upon r. Similarly, in this triangle, you can see sine alpha minus phi means this angle, sine alpha minus phi, that is y minus x upon r. So this complete is y minus x means this length upon hypotenuse means r. So you will get these two relations, add up these relations, and you will get the final relation 2y upon r, where y upon r is sine alpha. So you have this relation. So this is your second numerical based on steady state cornering. Let's see. The front axle of the car has pivot centers 1.1 meter apart. So the front axle of the car means this front axle of the car has pivot centers, that is C. Pivot center means C, 1.1 meter apart. This is your length C given to you, 1.1 meter. The length of each steering arm is 150. So steering arm length, that is R. This is your steering arm A, R, A and SB. This is small r, steering arm length, and it is given to you 150 mm. Wheel track rod, that is AB, the length is 1 meter given to you. Calculate wheelbase. You have to find wheelbase for perfect rolling of the car wheels when inner wheel stub axle is at 55° to the rear center line. So this is your rear center line, this is rear wheel, and this is your center line, and your axle makes angle 55 with the rear center line. It is given to me this angle is 55. If this angle is 55, the theta will be 90 minus 55, that is 35. So your theta comes out to be 35. Okay, so rest of the question we will discuss in the next part. Okay guys, thank you.